Lesson 112 is more about multiplication of radical expressions, and these will usually be like a pair of binomials, and they'll have radical expressions in them. You just expand them out just like you would if you didn't have radical expressions, and then simplify those radical expressions when you're done. So let's just do this just like they were variables or just regular numbers that didn't have radical signs. Start with the square root of 2, expand that over square root of 6 and 1, so you'd have square root of 2 times square root of 6 is the square root of 12. Then you add the square root of 2 times 1, so that would just be plus the square root of 2. Then you go to the 3, multiply it by the square root of 6, so you'd have plus 3 times the square root of 6, and then 3 times 1 is 3. Okay, so now there's that expression expanded. Look for ways to simplify that. Square root of 12, you could break that into 4 times 3 because you know the square root of 4 is 2. And so that will simplify to 2 times the square root of 3, and then plus the square root of 2, plus 3 times the square root of 6, plus 3. And so that would be the expanded form of that problem. Let's do another one. Just expand that out, starting with the square root of 6 on the left, and we'd multiply it by the 2 times the square root of 6. And so that would be 2 times the square root of 6 times square root of 6, which would be just be 2 times 6. And then square root of 6 times a negative 4, that would be minus 4 times the square root of 6. And then we'll multiply the 6 by 2 times the square root of 6, and we get plus 12 times the square root of 6. Then we multiply 6 by negative 4 and get a negative 24. Now let's simplify where we can. We have a 12 and a negative 24, so that would just be a negative 12. And then negative 4 times the square root of 6 plus 12 times the square root of 6 would add together to 8 times the square root of 6. And so there's our answer. Look at this next one. The square root of 3 times x plus the square root of 7, that quantity squared. So we have a pair of binomials that are identical. Square root of 3 times x plus the square root of 7. Now that x is not under the radical sign. It's out there by itself. Square root of 3 times x plus the square root of 7. And you can think of that, or you should think of it as multiplication. If you need to put a little dot there to remind you that that's multiplication, you can. So it's on the outside of the radical sign. So go ahead and multiply the square root of 3 times x in the first term with the 2 terms in the second binomial, and you'll end up with 3x squared, because square root of 3 times square root of 3 is just 3, right? And then you multiply it by the square root of 7, and that would give you the square root of 21x. Then go to the square root of 7, multiply it by the 2 terms in the second binomial. You'd get another square root of 21x, and then at the end you'll end up with a 7. So now let's simplify this by adding like terms, and we'll have 3x squared plus 2 times the square root of 21x, because there's 2 square root of 21x terms, plus 7. And so that's the answer there. Let's do one more. We'll expand this out, starting by multiplying 3x by the 2 terms in the second binomial, and we'd have 3x times 2x is 6x squared. 3x times the square root of 5y, that would be equal to 3 times the square root of 5xy. And that's kind of a long term there, but that's what it would be. And then we take the square root of 5y, multiply it by those second 2 terms, and we'd have 2, so plus 2 times the square root of 5xy. And then lastly, we'd end up with a 5y squared. Okay, so we can simplify that by adding those middle 2 terms together, because those are like terms. And so we'll end up with 6x squared plus 5 times the square root of 5xy, and then plus 5y squared on the end. And so there's the expanded form of those two binomials. So on problems like this where you have binomials that you need to expand, they have radical signs in them, you just work them like any other expansion of binomial problems. Okay, well that's all for lesson 112.